Bismillahirrahmanirrahim. Dear students, today we are going to discuss the problem about discrete time Fourier series here. The method is more or less similar to what we did for the continuous time Fourier series with a small change here. Now, if we need to write the periodic signal x of n, it will be equal to the summation k equal to we have n in this small brackets here. It means that we are talking about the n successive values of k here. Okay, so it means we need to have our time period. So if we need to have our time period, then we know that okay, my Fourier series coefficients will be, for example, if there are four, so I can say okay, these are the four successive values and of my Fourier series coefficients here. AK means this is my Fourier series coefficient and I can solve it using this formula here. Okay, and secondly, if you see here, we are talking about a discrete time, so that's why we have n here, and obviously the angular frequency is also represented in the discrete time here. Next thing is, if we see here the value of k, the value of k is basically the sum integer values here. So normally this formula x of n is we can say that this is basically the inverse discrete time Fourier series formula here. So let's start with first problem. Let's start with solving the first problem here. The first problem is we need to find the Fourier series coefficient for x of n equal to cosine of pi by 3 n here. Okay, so we need to find the Fourier series coefficient and we can also plot its magnitude and phase spectrum here. Now, first of all, since we are using the Fourier series for the periodic signal, so let's check if it is periodic or non-periodic. Of course, whatever is given to you should be periodic. Just to find the periodic or non-periodic, for second thing, we need to also find what is my fundamental period here. Okay, so let's suppose if you remember something from the periodic and non-periodic for tutorial, how we find it for the discrete time with only one frequency component here. We say that, for example, the omega naught is equal to here pi by 3 here. So we say that for a signal to be periodic, we say that the omega naught by 2 pi should be equal to k by n here, where the k by n should be a rational number to make a periodic here. So we need to check for this condition here. Okay, so in this case, omega naught will be equal to pi by 3 multiplied by 2 pi will be equal to k divided by n here, which is equal to pi by, sorry, pi will cancel here. So I can have basically 1 divided by 6, which will be equal to k by n here. Now, for a periodic signal, we say that the ratio of k by n should be a rational number, and in specifically we say that this factor should be the division or the ratio of two integer values, and obviously it is the integer value, so we can say that this is a rational number here. Okay, so if it is a rational number, we can find it like it will be from here. Even you can say n equal to 6, or we can say n equal to 6k here. So we can say for the smallest value of k, which is 1, n will be equal to 6. So this is your fundamental period here. Okay, so now we know that for this particular signal, the fundamental period is 6 here. So we can say like I'm just writing it here. N naught here is 6 for this particular question here. Okay, so now to find the coefficients here, what we will be doing here, we are going to expand them into the exponential form here. So for the cosine, it will be 1 by 2 e power j. My frequency here is pi by 3, so it will be pi by 3 and plus 1 by 2 here e power minus j pi by 3 and here. So now you already know from this formula, I have summation with a of k e power j k omega naught n. So what I will be doing here, I will try to write it like a of k into e power j. I'm just writing the value of k in the brackets because this will tell me what coefficient it is, omega naught n here. Okay, just to make the things easier here. So I rewrite this one as 1 by 2 into e power j k omega naught. So obviously my omega naught here is pi by 3. So it will be e power j. The value of k will be 1 into omega naught, which is pi by 3, n, plus 1 by 2 e power j minus 1 into pi by 3 n here. Okay, so now I know that my coefficients are 1 and minus 1 here. So it means that from here I can rewrite like the Fourier series coefficients will be equal to my coefficients here, Fourier series coefficients. So I can say like a of 1 will be equal to half and a of minus 1 is equal to half here. So I have the coefficient as half and half here. Now remember that we already discussed that the number of coefficients I have is 6. So it means that if I talk about this one, okay, let me plot, then I discuss with you this thing basically. Next thing is how can we find the magnitude spectrum here? So the magnitude spectrum will be magnitude spectrum. It's quite straightforward. The magnitude will be, and the magnitude will be a1 magnitude will be equal to half and a minus 1 magnitude will be equal to half again here. So we have the magnitude as 1 by 2 here for both of them. Okay, so if we want to plot it, we can plot them as we can say basically this is like 1, this is at 1 I have half, at minus 1 I have half here. Okay, and this is basically half here. This is your a of k magnitude and this is your k here. Okay, similarly we can have the phase here. For the phase spectrum, what we are doing here, basically we will find the phase here. So phase of AFN will be equal to tan inverse imaginary 1, imaginary 0 divided by half here, which will give me tan inverse 0 here. Tan inverse of 0 is 0 here. Similarly, the angle of AF minus 1 will be 0 here. So basically for the phase, let's suppose I say that this is the phase of A of k here. So this is 0 and 0 here at 1 and minus 1 here. So it means all the values here are 0 for the others one. Okay, this is the value here. Now remember that for the discrete time, when we find the value of n, naught here, which was 6, it means I'm going to have the 6 consecutive values for my coefficients here. So what I can say here, for example, I can say that my values is equal to a of minus 1, then a of 0, then a of 1, then a of 2, a of 3, a of 4. So it means total 6 here. So it means I'm going to have my Fourier series coefficient for these values here. So obviously for the half, this is half, this will be 0, this is basically again half here, this is 0, 0 and 0 here, and after that it will repeat again. Okay, like for example, if I want to find, I can say that okay, a of minus 1 plus my value of n here, so it means it will give me a of 5 here. So it means 1, 2, 3, 2, 3, 4. At 5, it will be again half here. And similarly here. Maybe here maybe. At -5, it will be. So it means this thing will be repeated again here. Okay, so that's why we want to find the value of n. So we know that, okay, how many values we have here. Clear? So you can start it from anywhere. You can say, okay, I have basically 6 values. So I have 1, 2, 3, 4, 5, and 6. So this is all your, if you want to start from here. Okay, like if you want to make it from 0 to, for example, I want to make it the value of n from 0 to 5 here for this particular n here. So you can say, okay, this is 0, 1, 2, 3, 4, 5. So my one coefficient is at 1, the other coefficient is at 5 here, if you want to make all of them on the positive side here. Okay, but if you do like this, it will be more than enough. You can say, okay, other coefficients are other coefficients in fact Fourier series coefficients are 0 here. Okay, so it's like more or less the same what we did previously for the continuous time here. Okay, now let's have another example. We have x of n is equal to cosine square root 2 pi n here. Now, before starting, we said that basically the Fourier series we are normally doing it for the periodic signal. Not normally, in fact, we are doing the Fourier series for the periodic signal. And if it is a non-periodic signal, we are going to do the Fourier transform for it. So let us first check if it is the periodic or non-periodic. So how we check it? We say that omega, in this given case, is square root of 2 pi here. Okay. So condition was the ratio of k by n will be equal to omega naught, or maybe omega naught by 2 pi will generate a ratio which is k by 2 pi by n, and it should be rational here to make it periodic. Okay, for periodic here. So now let's substitute here. I'm just write k by n here. So just to have the ratio, because I'm interested in finding k by n here, omega naught is equal to, I can say this is my omega naught here. So this will be square root of 2 pi by 2 pi here. So obviously pi will be cancelled here, and I have basically square root of 2 by 2 here. Okay, I mean if you further simplify it, you are going to have like basically you can have even this one, even it will give you the non-periodic or non-rational number here. Okay, so you can even check it, like if you can represent 2 as square root of 2 is equal to, this is square root of 2 square root of 2, so this will cancel here. I can have 1 underscore square root of 2 here. Okay, so this is obviously non or irrational, non-rational. You can say this is basically irrational number here. So if it is irrational number, then we can say this is a non-periodic sequence here. So in case of a signal which is not periodic, we cannot expand it. So we can say that. So we cannot. So the given signal cannot be expanded as Fourier series. Also, we don't have any magnitude and phase spectrum for it. Okay. So normally, I think whenever you have a problem, most probably you will get a periodic signal, but for the discrete time, better you can check it. Okay. Okay. Now let us have a problem. A different problem. I mean, basically, what we are given a signal x of n in the discrete time with only 4 elements inside it, and it says that it is a periodic signal. Okay, we know it is a periodic signal, and the fundamental period, you can say n naught will be equal to 4 here. Okay, so and I have only 4 value with this value at n equal to 0 here. So first of all, we know that, I mean, if you refer to the previous formulas, if I need to find the Fourier series coefficient directly, it will be equal to 1 divided by n. The value of n is the successive values of n, x of n into e power minus j k omega naught n here. Okay, and basically it is going to be basically we can say that basically the formula, I can say like here the value of n can be, if I say it is starting from 0 in this case, for example, capital N minus 1 means I have to have 4 values here. Okay, so it means I will run from 0 to 3 here. Now, first of all, let us find the generalized form here. So for that, we need to have what is my omega naught here. So obviously, omega naught in discrete time will be equal to 2 pi divided by n naught, or you can say n here, okay, whatever you say. So let's suppose it will be equal to 2 pi by 4 here, which will be equal to pi by 2 here. So my omega naught here is pi by 2 here. Second thing is, okay, let us find a of k here. So a of k will be equal to 1 divided by 4 summation. In fact, I wrote n naught here, so you can also say this is n naught here. So n will be equal to from 0 to 3. I have x of n into e power minus j k, some integer values basically, of course, and I'm going to have omega naught. Omega naught is pi by 2 here, so let me write pi by 2 n here. Okay, so this is the general form. So let us expand it. So it will be equal to 1 by 4. When you run it, you are going to have n0. It means I'm going to have x of 0. Okay, it will be like x of 0 into e power, the value of n is 0, so it will become e power 0 plus x of 1 into e power minus j k pi by 2, and it will be 1 basically, plus x of 2 into e power minus j k pi by 2 plus x of 3 into e power minus j k pi by 3 pi by 2 into 3 here. Okay, now if you see here the value, this is x0 is 1, no problem, x1 is 1, x2 is 0, and x3 is 0 here. So it means x2 is 0, so this will be 0 0. So it means anything multiplied with 0 will give me 0 here. So it means I am going to have 1 by 4 here, e power 0 is 1 here, and so I will get 1 plus this value is 1 here, so 1 multiplied by e power uh, okay, e power minus j k pi by 2. Okay, and you can expand it, you can say it's like equal to 1 by 4 plus 1 by 4 into e power minus j k pi by 2 here. Okay, this is basically your a of k here. This was your a of k here, the general form here. Okay, now normally, I mean, when you are finding 0 here, so I am not going to have this term here. Okay, but let us solve it basically, because I mean, when you put 0 here, this will become 1, so you only the formula will involve only these things here. Okay, but anyway, it will be removed here. So now this is my general way here. Now I need to find, I say that the value of capital N naught is 4 here, and I'm starting from 0 here, so it means I need to find the coefficient at 0, 1, 2, and 3 here from this formula, general formula which we obtained here. So it means that a of 0 will be equal to, it will be equal to 1 by 4 plus 1 by 4 into e power 0 here. So this will be basically equal to 1 by 4 plus 1 by 4 will be equal to 2 by 4, which is equal to 1 over 2 here. Okay, similarly a1 will be equal to 1 by 4 plus, now just one more thing again quickly. If you see here, now I'm replacing the value of k here, so this value is basically replaced to solve it. So 1 by 4 plus 1 by 4 into e power minus j, the value of k is 1, so 1 multiplied by pi by 2 here. Okay, this is what I'm going to have here. And okay, so we will solve it basically. Or if you want, keep it like this, then a of 2 will be equal to 1 by 4 plus 1 by 4 into e power minus j, 2 pi by 2 here. So 2 will cancel with this one, so I will get 1 by 4 plus 1 by 4 into e power minus j pi here. Okay, similarly a of 3 will be equal to 1 by 4 plus 1 by 4 into e power minus j, it will be like 3 pi by 2 here. So we were able to find A0, A1, A2 and A3 here. So if you want, you can find the magnitude and phase spectrum quickly here. So let us have it here. For example, for A0, I'm talking about the magnitude here, okay? Talking about the magnitude spectrum here. So A0 will be equal to A0 magnitude will be basically equal to 1 over 2 here, which we found previously here. A1 magnitude will be basically equal to A1 magnitude. Okay, now if you see here, I have an exponential here. Okay, so let us try to solve what it means here. What is the value here? So how we will find? We say that e power minus j pi by 2. So we can use the Euler's formula here, which will be equal to cosine pi by 2 minus j sine pi by 2 here. So cosine pi by 2 is 0 minus j sine pi by 2 is 1 here. So it means I will get minus j here. So it means this is equal to 1 by 4 plus 1 by 4 uh, j maybe here 1 by 4, not plus, in fact this is minus here because this is minus j here, so it will be minus here. Okay, so I can find the magnitude of it. And how I'm going to find the magnitude? The magnitude is simple. The real square plus the imaginary part square, real square 1 by 4 here, plus the imaginary part square whole square root here. That means I will have 1 by 16 plus 1 by 16, which will be basically 2 by 16 maybe, and it is equal to square root of 2 by 4 here. Okay, so when you solve it, you will get 0.353 here. At least this is the value I got. Similarly, for the next one, e power minus j pi. E power minus j pi means this will be equal to cosine pi minus j sine pi here. So sine pi is equal to 0 and cosine pi is equal to minus 1 here. So it means a of 2 magnitude will be equal to 1 by 4 minus 1 by 4 here, which will be equal to 0 here. Similarly, a of 3 magnitude will be equal to, now what is e power minus j 3 pi by 2 cosine 3 pi by 2 minus j sine 3 pi by 2 here. Okay, so 3. Okay, so basically 2 pi by 3 pi by 2 means it's like 270. So cosine 270 will be equal to basically 0 minus j, and sine 270 is minus 1 here. Okay, so it means I will get j here, just to show you how the graph is normally for the sine. This is something like this. So this is basically sine 0, sine 90, sine 180. I mean, if I say this is 1 and minus 1 here, this is sine 180, then this is 270 and sine 360 here. Okay, similarly for the cosine, the curve is something like this. So this is cosine 0, cosine 90, cosine 180, cosine 270, which is 0 here, and this will be cosine 360, 1 and minus 1 here. Okay, so it means I will have 1 by 4 plus 1 by 4 j here, and it will be, I think, the same value what we have. Which will be basically the same as 0.353 here, because I mean when you take the square here, minus and plus will give me the same values here. So I mean more or less same, but only this is will become positive in that case. So now if we need to plot it, so we can plot it directly here. We can plot it like 0 is half, so let's suppose this is half, 0.5 here, and at 1 this is 0.3, so let's suppose if this is 0.5, so this will be 0.25. So it means let's suppose something here, 0.35 here. This is 0.5 here, this is 0.353 here. And A2 is 0 obviously, and A3 is again the same value here. Okay. Similarly, I mean basically, I just only take from 0 to 3. So obviously, we said that the magnitude spectrum should be even. So it means I'm going to have the value here, the same value, minus 1, minus 2 will be 0, and minus 3 will be again the same value here, and it will repeat. The things will repeat here. After that, like it will come again this thing, and come again this thing, and so on. It will repeat here, you can see. Okay. Similarly, if you need to go for the phase spectrum, let's have a fixed spectrum here. So I'm just doing phase spectrum here. For the phase spectrum, obviously the angle of A0 will be equal to tan inverse of 0 here, so which is equal to 0 here. Angle of A1 will be equal to tan inverse. Now the real part here is 1 by 4. Sorry, imaginary part here is minus 1 by 4 divided by the real part is 1 by 4 here. So it means I will have tan inverse of minus 1 here, which is, I think, if I'm not wrong, is minus pi by 4 here, like minus 45 here. Then angle of A2 will be equal to tan inverse of this is 0 basically. Okay, so my is 0 here, so 0 by 0 we cannot have. This is basically some undefined number, so we cannot find, so we can say this is undefined here. Okay, so obviously we are not going to have, because in fact the coefficient here is 0 here. Sorry, if you see here, when we find e power minus j pi by 2, so this was giving me minus 1 here, so it becomes 0. So obviously this coefficient is 0 here, and against this coefficient we don't have any phase here. Okay, so I mean we cannot solve it. That's what I write undefined for this one basically. Okay, so there will be no coefficient, no angle here, because there is no coefficient even here. The next one is, so it's better not to write it as undefined. We can say, okay, there is no coefficient here, so it means there will be no phase also for A2 here. Okay. Similarly, for the A3, it will be like tan inverse uh, 1 here basically. Okay, so it will become pi by 4 here. You can easily plot it here now. You can see here, again, this is against k here. Okay, and this is A of k magnitude here. This is angle of A of k. This is k here. So at 0, it is 0. At 1, it is minus pi by 4. Let's suppose I said this is minus pi by 4 here. So at 1, it is minus pi by 4. And at 2, I don't have anything, so leave it. At 3, you can say this is pi by 4 here. And then it will be 0 again, and so on here. Similarly, I mean, it should be the odd symmetric, so it means I'm going to have here at 1, at minus 1 I will have here, and don't have an, at minus 3 I will have something here. And so on. This will repeat here basically. Just to show you, I mean, why I have this value basically, like basically, for example, for this one, for example, I say that A of minus 1 plus the n naught is 4 here, so it means I'm going to have A of 3. So the same value is repeating at A of 3 here, like what we did previously. Okay, so but remember that it should be odd symmetric here. The phase spectrum and the magnitude spectrum should be even symmetric here. Okay, so this was all about today's, and I mean I just tried to solve minimum questions. I mean the other type of question we already solved last time here. Okay, so this was all about discrete time Fourier series. I mean, wish you all the very best. Okay, and this is our last tutorial. Okay, most probably I'm not going to have more tutorials unless I was told to do it. Okay, thank you so much. Assalamu alaikum.